Welcome to the technical demonstration of EGI's recommended workflow for building a conformal atlas head model in the modal image pipeline, or MIP. For this workflow, you must have GeoSource 3.0 Intermediate or Advanced. Before you begin, you must have a solved geodesic photogrammetry file for your subject or patient. In this workflow, the 3D sensor positions from a given individual are used as the geometrical target for warping a given atlas. Create a directory for your resulting files that will be the output from the MIP. Right-click and select New Folder. Name this folder that will contain the pieces from the MIP process. I'm going to choose PTX for the subject ID and then CAHM, the acronym for Conformal Atlas Head Model. Move the GPSR file you will be using to build the conformal model to this new folder. Launch the MIP. Choose the workflow. This workflow is for the conformal atlas head model, so we will choose Create CAHM from individual sensors. Click Next. Click Browse and then select the GPSR file from the new folder that you created. Once you select your GPSR file, it will show you the path to where the output file will be saved. Click Next. Set an output prefix to be appended to the output file names. Click Next. Choose your atlas head model. The atlas you choose here will conform to the sensor cloud created with the GPSR you chose. Choose an atlas that is the closest to the age of the individual as possible. Click Next. You can see the steps in the workflow as they complete. When it comes time for user input in Step 5, you will see the MIP window open. Please wait about 10 minutes until the next user input is needed. We're now in Step 5, and this is where we will evaluate the sensor placement. You can see the GPS images on the right and the atlas model on the left with the sensors. Expand the window to full screen. Evaluate the placement of the sensors on the atlas model. This model on the left will eventually shrink or grow to accommodate the patient's head shape and size indicated by the sensor coordinates. If necessary, adjust the sensors to the anatomical features on the atlas model so that they reflect the relationship between the sensors and the anatomical features in the GPSR images. Evaluate the relationship to the following anatomical features: the Nasion and brow point ridge here, the left and right face points and their relation to the nostrils, and the preauricular and neck points to the ears. Keep in mind you're not evaluating the relationship of the sensor placement to other sensors. You're trying to get the relationship of the sensors to the anatomical features so that they match in both views. Always evaluate from more than one camera angle. You can click and drag the model on the left, or choose the camera numbers in the menu by clicking the up and down arrow keys. Zoom in and out of an image by holding down the right-click button and dragging your mouse. Move the GPS image within the window by holding down the Shift key and then the right-click and drag. To make adjustments to the placement, you will move the landmark points. The landmark points are identified by the blue and red dots on the Atlas model. Let's start with evaluating the facial points. Look at the relationship and spacing of the sensors on the face to the nostrils. Now compare this placement to the sensors on the Atlas model. Align the Atlas model so that it appears like it is in the same camera view as the patient or subject in the GPSR image. The relationship to the nostrils here looks appropriate. Next, look at the Bayesian point. How do the sensors line along the brow? The Bayesian point appears to need to be moved up slightly. When you adjust the Bayesian landmark up, it will also raise these other sensors along the brow up as well. Now evaluate the ears. Make sure there are no sensors on the ears. If you have sensors on the ears, you will need to adjust the landmark points either in front or behind the ears to adjust the sensors along the ears to the correct position. You can use different groupings of sensors in triangles to help you evaluate if movements need to be made. For example, you could create a triangle among these three sensors here and see if the orientation and direction of that triangle matches that of the patient in the right. This one does. You can similarly do this above the ear. For example, we have this grouping you could make here. And we can see that goes just above the ear. And on this side, the same. In this triangle, we know that the sensor on the left should be very close to touching the ear. To adjust a landmark point, click on the Landmark tab. Check the radio button next to the landmark point you would like to adjust. I'll start with the Bayesian point. In our evaluation, we decided that the Bayesian point needed to move up higher on the Atlas model. Adjust the individual coordinates of the landmark point using the controls underneath the radio button, X, Y, or Z. You can also shift and click on the Atlas model to the place where you would like the landmark to move. Always confirm your movement in at least 2 camera angles. If you make a mistake, you can always hit the Undo Selection button, and the sensor or the landmark point will move back to the last location before you moved it. If you would like to redo, you can hit the Reset Selection button. Now that we've adjusted the landmark points that are necessary, we can enter the Bayesian to Indian distance. This is used to help calculate where CZ should be on the conformal atlas model. If you do not have this distance for your patient, then the software will use the default atlas CZ position. When you are finished updating, you can click the Update button, and the MIP will re-register the sensors to the atlas, and you will have another chance to confirm before proceeding. Are you sure you would like to apply the changes you've made to this model? To proceed to register changes, click Yes. The Bayesian to Indian distance is not set. Do you want to proceed with the default CZ position? Yes. You will be able to see the steps as they proceed in the window. When it gets to step 5, you will have time for user input again. Repeat the steps for evaluating the sensor placement on the atlas model. Review the facial electrodes, the electrodes around the ear. You can see the sensors along the brow ridge have been moved higher up. It is common to make several adjustments throughout this process. After you review the updated model, if you need to make more changes, proceed to the Landmarks tab and adjust the landmark points as needed. If you are finished with this model, click the Next button. Do you want to proceed? Yes. If you do not have the individual's conductivity values, then we recommend to use the default values for the atlas model. Enter the job name. The job name is going to name the file you will use in the next step of the workflow. The job name cannot have any spaces in it. Click Create Job. You will see the message with feedback that the job is complete. You can exit the MIP. Review the files that were created during this process. This is the file name that we entered in the beginning. These 3 files were generated: anatomy, geometry, and this is the job name that we entered at the very end for this file right here. The next step is to create an electric head model. Thank you for watching the technical demonstration of EGI's recommended workflow for building a conformal atlas head model in the Modal Image Pipeline, or MIP. For further information, please contact EGI support.